Look around you for a moment. No, really, stop and actually do it. Look at your hands. Look at the texture of your skin, the subtle shifts in color, the way light reflects off your fingernails. Look at the room you're in, the walls, the objects, the sense of space stretching out in front of you. It feels immediate, doesn't it? Solid, reliable, as if what you are seeing is simply there, as if your eyes are little windows, passively observing a world that exists exactly as it appears. That is the most natural assumption a human being can make. It is also completely wrong. Not slightly wrong, not technically flawed, completely, fundamentally, astonishingly wrong. You are not seeing reality. You are seeing a reconstruction, a carefully edited, highly compressed, deeply distorted version of something that exists far beyond your direct experience. And the part that makes this truly unsettling is not that your senses are limited. We all know that in a vague way. It's how radically, how absurdly limited they are compared to what is actually out there. Take something as simple as color. You look at a red object and you think that object is red, but redness does not exist in the object. There is no property inside that thing labeled red. What exists are electromagnetic waves, oscillations in electric and magnetic fields, vibrating at around 430 trillion cycles per second. That's what red actually is. Your eyes do not see waves. Your brain cannot process trillions of oscillations per second. So what does it do? It invents a sensation. It creates redness as a kind of internal shorthand, a symbolic translation. The same is true for every color you have ever seen. Blue is not blue. Green is not green. These are not features of the external world. They are features of your nervous system. Now here is where it gets interesting. The visible spectrum, the tiny slice of electromagnetic radiation your eyes can detect, is unbelievably small. It runs from roughly 400 to 700 nanometers in wavelength. That's it. That narrow band is what you call light. But the electromagnetic spectrum itself stretches far beyond that. Radio waves kilometers long, microwaves, infrared, ultraviolet, X-rays, gamma rays. Your brain throws almost all of it away, not because it's unimportant, but because evolution did not require you to see it. If you could suddenly perceive the full spectrum, your entire understanding of reality would collapse instantly. The room you're in would no longer look empty between objects. It would be flooded with signals. Radio transmissions passing through walls, infrared heat signatures glowing from every surface, high-energy particles streaking invisibly through your body. You would not recognize your own world. So your brain does something very clever. It hides almost everything. It filters reality down to a thin, manageable sliver. And then it paints over that sliver with colors, textures, and shapes that feel intuitive. You are not seeing the world. You are seeing a user interface. And like any interface, it is designed not to show you the truth, but to help you survive. Think about it like this. When you use a computer, you don't see voltages moving through circuits. You don't see binary code flipping between zeros and ones. You see icons, you see folders, buttons, images, simple representations that allow you to interact with something vastly more complex. The icon of a trash can on your screen is not a real trash can. It doesn't contain your files physically. It is a symbol, a convenient lie that helps you navigate the system. Your perception of reality works the same way. The objects you see are icons. The solidity you feel is an interpretation. The smoothness of a surface is not smooth at all when you zoom in. It's jagged, chaotic, full of gaps and motion at the atomic level. But if your brain showed you that, you wouldn't be able to function. You wouldn't be able to pick up a glass or walk across a room without being overwhelmed by complexity. So instead, your brain simplifies. It lies to you, consistently, predictably, usefully. And here's the part that really starts to twist your mind. This is not a flaw. It is not a limitation we might one day overcome. It is the entire strategy of perception. Evolution does not reward organisms for seeing reality as it truly is. It rewards them for seeing what is useful. If an organism perceives something accurately, but that accuracy does not help it survive, it gains no advantage. In fact, it may be a disadvantage. Imagine a creature that sees the full quantum mechanical structure of everything, the probabilistic clouds of electrons, the constant fluctuations of energy, the underlying uncertainty built into the fabric of the universe. That creature would be paralyzed. It wouldn't know where one object ends and another begins. It wouldn't have stable reference points. It wouldn't be able to act. You, on the other hand, see a chair, a simple, solid, reliable chair, and that illusion allows you to sit down without thinking about quantum fields or electromagnetic forces. Your brain has traded truth for usability, and it has done so with astonishing efficiency. Now, you might be tempted to say, well, sure, maybe the details are simplified, but the overall picture is still real. A chair may not be perfectly solid, but it's still there. That intuition feels reasonable. It feels grounded. It is also where things start to fall apart completely. Because when you dig deeper, when you go beyond atoms, beyond molecules, beyond even particles, you find something that does not resemble anything like the world you think you are seeing. At the fundamental level, reality is not made of little solid bits of stuff. It is made of fields, continuous entities that exist everywhere in space, fluctuating, interacting, vibrating. What you call a particle is not a tiny object. It is a localized excitation in a field, a kind of ripple. So the electrons in your body are not little balls orbiting a nucleus like planets around a sun. That picture you learned in school? That's another interface, another simplification. In reality, electrons exist as probability distributions, clouds of possible positions described by a mathematical function. Until you measure them, they do not have a definite location. They are not somewhere. They are described by a spread of possibilities. And yet when you look at your hand, it appears perfectly solid, perfectly stable. No flickering, no uncertainty, no probability clouds, just flesh and bone. The reason is not that the uncertainty disappears. It's that your brain cannot represent it. It collapses all that complexity into something usable, something stable, something that allows you to interact with the world without going insane. But the cost of that stability is accuracy. You are not seeing what is there. You are seeing what your brain can handle. And the gap between those two things is far larger than most people are willing to accept. Because once you admit that your perception is a constructed interface, a filtered, simplified model, you have to confront a very uncomfortable question. How much of what you think is real is actually just part of that model? And more importantly, how much of reality is completely hidden from you, not because it's subtle, not because it's far away, but because your brain has decided it's not worth showing you at all. Now, if that were the end of the story, it would already be unsettling enough. But it gets worse, much worse, because everything I've just told you still operates under a comforting assumption that there is a stable, objective reality out there, and your brain is merely giving you an incomplete picture of it. That assumption feels safe. It allows you to say, okay, I'm not seeing everything, but at least there is something definite to see. Physics is not so generous, because when you push into the deepest levels of our best theories, that sense of a fixed, observer-independent reality starts to dissolve. And I want to be very careful here, because this is where people tend to drift into vague mysticism, and I have no interest in that. This is not philosophy. This is not speculation. This is what the equations say, equations that have been tested to absurd precision, equations that underpin technologies you use every day. At the quantum level, the idea that objects have definite properties independent of observation becomes extremely difficult to maintain. Take a simple experiment, the double-slit experiment. You fire electrons one at a time toward a barrier with two slits, and you detect where they land on a screen behind it. If electrons were little particles, you would expect them to go through one slit or the other, producing two clusters on the screen. That's not what happens. What you get is an interference pattern, a series of bright and dark bands that can only be explained if the electron behaves like a wave, passing through both slits simultaneously and interfering with itself. That's strange enough. But here's where it becomes truly bizarre. If you place a detector at the slits to observe which path the electron takes, the interference pattern disappears. The electron now behaves like a particle, going through one slit or the other. The act of measurement changes the outcome, not in a vague philosophical sense, but in a precise, measurable way. The system does not settle into a definite state until an observation is made. Now, people argue about what this means. There are different interpretations, different ways of understanding the mathematics. But the core fact remains. The classical picture of a world made of objects with definite properties, existing independently of observation, does not fit what we see at the quantum level. And remember, this is not some exotic corner of physics. This is the foundation. Everything you see, every atom in your body, every photon entering your eye is governed by these rules. So the very act of seeing reality is built on processes that do not behave in the way your intuition expects. Your brain presents you with a stable, continuous world, but underneath that presentation is a layer of uncertainty, probability, and context-dependent behavior that never makes it into your conscious experience. It's as if you're watching a perfectly smooth movie, unaware that it's made of discrete frames, unaware that the frames themselves are generated by a system that doesn't even fully decide what they are until the moment they're observed. And here's the part I find most fascinating. You cannot step outside this system. You cannot remove the interface and look at reality as it is, because any attempt to observe reality is itself processed through the same perceptual machinery. You are trapped, not in a prison, but in a translation layer. Every measurement you make, every experiment you perform, every observation you record is filtered through instruments, through interpretations, through models that ultimately connect back to human perception. Even when we build detectors to measure things, we cannot sense directly. Radio telescopes, particle accelerators, quantum sensors. We convert their outputs into forms we can understand. Graphs, images, numbers. We never escape the interface, we only extend it. And yet, despite all of this, despite the layers of abstraction and limitation, we have managed to uncover something extraordinary. We have found that beneath the illusions, beneath the simplifications, there are patterns, mathematical structures that describe the behavior of the universe with incredible accuracy. The equations of quantum mechanics, the theories of relativity, the models of particle physics. They do not look like the world you see, but they predict it with astonishing precision. So in a strange way, we have access to reality not through direct perception, but through mathematics. Not by seeing it, but by inferring it, by building models that go beyond our senses and then testing those models against observation. And this creates a kind of double vision. On one level, you live in a world of colors, shapes, and objects, a world that feels immediate and real. On another level, you understand that this world is a projection, a useful fiction built on top of something far more abstract and far less intuitive. And the tension between those two levels is where things become truly interesting. Because once you start to see the cracks in the interface, once you start to realize that your perception is not a window but a construction, you can't unsee it. You begin to question things you never questioned before. You begin to notice how easily your brain fills in gaps, how confidently it presents guesses as facts, how it creates continuity where none exists. You start to realize that what feels like direct experience is actually the end result of a long chain of processing, interpretation, and simplification. And that realization does not make the world less real. It makes it more mysterious. Because now the question is no longer just, what is reality, but what is it that we are actually experiencing, and how far is that from the truth? And once you start asking that question seriously, once you follow it all the way down, you find yourself standing at the edge of something deeply unsettling, the possibility that the reality you trust, the one you navigate every day without thinking, is not just incomplete, but fundamentally different from what actually exists. Now we arrive at the part most people instinctively resist, because everything up to this point, as unsettling as it may be, still allows you to hold on to one comforting belief, that beneath all the distortions, beneath all the simplifications, there must still be something solid, something stable, something that exists exactly as it is, independent of how you perceive it. That instinct feels reasonable. It feels necessary. But the deeper physics goes, the less that solid foundation resembles anything your mind can comfortably understand. At the most fundamental level, reality does not look like objects sitting in space, moving through time. It does not look like particles bouncing around like tiny billiard balls. Instead, it looks like mathematics, pure, abstract structure. And that is not a metaphor. The most successful theories we have, the ones that predict experimental results with astonishing precision, do not describe things in the way your brain imagines them. They describe relationships, symmetries, probabilities, and fields. What you call a particle is not a tiny object. It is a localized vibration in a field that exists everywhere. What you call empty space is not empty. It is filled with constant fluctuations, temporary bursts of energy appearing and disappearing in accordance with quantum laws. Even the idea of nothing happening turns out to be an illusion, because at the smallest scales there is always activity. Now pause and think about what that really means. The world you experience, filled with solid objects, stable forms, continuous motion, is not what exists at the deepest level. It is a translation, a rendering, a kind of projection your brain creates from underlying processes that do not resemble anything like your everyday experience. There is no redness, no smoothness, no solidity in the fundamental description of reality. Those are layers added by your perception. They are useful, but they are not fundamental. And here's where things become truly disorienting. When you strip away those layers, what remains is not a hidden version of the world you recognize. It is something entirely different, something abstract, something that does not depend on your senses, your intuition, or your ability to visualize it. Reality, at its core, does not care whether it makes sense to you. It does not adapt itself to your expectations. It simply is. Yet somehow, from this abstract foundation emerges everything you experience, your body, your thoughts, the objects around you, all of it arising from patterns within these underlying structures. It's like trying to understand a symphony by analyzing air pressure waves. The connection is real, but the translation is enormous. The richness of experience comes from layers of interpretation built on top of something far more fundamental and far less intuitive. At this point, it is very tempting to step back and say, if reality is that strange, then maybe we can never truly know it. But that conclusion, while understandable, is not entirely accurate. Because although you may never directly experience reality in its raw form, you can still understand aspects of it through models, through mathematics, and through careful experimentation. Science does not rely on seeing reality as it is. It relies on building descriptions that work. Descriptions that predict outcomes, that reveal patterns, that allow us to interact with the world more effectively. And that is the key shift in perspective. You are not trying to see reality, You are trying to infer it. You are building models that extend beyond your senses, using tools that translate abstract structures into forms you can analyze. Mathematics becomes your window into a world that cannot be directly perceived. Experiments become your way of testing whether your models align with what actually happens. So you lose something, the intuitive, comfortable feeling that you are directly observing the world. But in exchange, you gain something far more powerful: the ability to understand a universe that is deeper, richer, and more complex than your senses could ever reveal. Now comes the final twist, the one that changes how you interpret everything you experience. If you are not seeing reality directly, if what you perceive is a constructed interface, and if even your sense of self is part of that construction, then the question, "Is this real?" starts to lose its meaning, because clearly the world you experience is not false, it is not arbitrary, it has structure, consistency, and predictability. You can interact with it, you can make decisions based on it. It responds in reliable ways. If you drop an object, it falls. If you touch something hot, it burns. These are not illusions in the sense of being meaningless or disconnected from reality. They are part of a system that is tightly constrained by the underlying structure of the universe. Your perception is not inventing reality, it is translating it. And that distinction is crucial, because it means your experience is not a lie. It is a simplified, evolutionarily optimized representation. Your brain is not trying to show you the truth. It is trying to help you survive. It highlights what matters for action, not what is fundamentally accurate. It compresses an unimaginably complex universe into a manageable format. Think of it like a map. A map is not the territory. It distorts distances, simplifies features, omits details, but it is still useful. It still reflects something real about the world. Your perception works the same way. It is a map, not the territory. Once you understand this, something important happens. You begin to realize that your intuitions, your sense of what is obvious, what is natural, what makes sense, are not reliable guides to the deepest levels of reality. They are products of the interface. They evolve to help you navigate a very specific environment, not to understand the fundamental nature of the universe. And this realization changes how you approach knowledge. Instead of insisting that reality must conform to your intuition, you accept that your intuition may need to be abandoned. You allow the evidence, the mathematics, the experiments to guide you, even when they lead to conclusions that feel strange or counterintuitive. This is exactly what has happened in modern physics. The discoveries that have reshaped our understanding of the universe, relativity, quantum mechanics, field theory, did not emerge because they felt intuitive. They emerged because they worked. They explained observations. They made accurate predictions. And over time, we learned to trust them, even when they contradicted our everyday experience. And that brings us to perhaps the most remarkable part of this entire story. You are a biological system that evolved to survive on a small planet using a simplified model of the world. Your senses are limited. Your brain filters and reconstructs information. Your perception is an interface, not a direct window into reality. And yet, despite all of these limitations, you are capable of discovering that the interface exists. You are capable of questioning your own perception. You are capable of uncovering structures that go far beyond what you can directly experience. You can look at the model your brain constructs and realize that it is a model. That is extraordinary. And it means you are not completely trapped by your limitations. You cannot escape them entirely. You will always perceive through some kind of interface, but you can push against them. You can refine your models. You can extend your understanding. You can get closer, not by seeing reality directly, but by building better descriptions of it. So no, you are not seeing reality, but you are not blind either. You are standing at the edge of something vast and incomprehensible, looking through a narrow, carefully constructed window. And through that window, imperfect as it is, you are beginning to glimpse patterns, structures, and laws that reveal something real about the universe. The more you learn, the more you realize that the world you experience is just the surface, a thin layer built on top of something far deeper. And that deeper reality does not look like objects or colors, or even time. It looks like relationships, equations, interactions, something abstract yet profoundly consistent. And perhaps the most humbling realization of all is this: the universe is not obligated to make sense to you. It is not designed for your understanding, and yet somehow you can understand parts of it anyway. You can build theories that reach beyond your senses. You can uncover truths that your brain was never designed to perceive. And in doing so, you participate in something remarkable, not just experiencing the world, but gradually uncovering the structure behind it. So when you look around you at the colors, the shapes, the solidity of things, remember this: you are not seeing reality as it is. You are seeing a translation, a beautifully crafted, highly effective interface that allows you to navigate a universe far more complex than you can imagine. And beyond that interface, beyond what you can see, touch, or intuit, there is something deeper, something stranger, something that does not fit into your expectations, but reveals itself through patterns, through mathematics, through careful observation. You are not outside it, looking in. You are inside it, trying to understand it. And that is what makes this whole thing so fascinating, because the more you learn, the clearer it becomes. Reality is not what it looks like. And yet, somehow, you are still able to uncover it.